Welcome students. So in last class we have discussed about electric current, resistance, Ohm's law and combination of resistances. In the combination of resistances we have discussed about series combination as well as parallel combination. Today we will see about the electric energy. So in the starting of the chapter we have read that electricity is a form of energy. Energy means it is doing some work. As it is doing some work, how much work it is doing? What is the amount of energy? What is the formula for energy? Everything we will discuss in this class. So today we will read about electric energy. Electric energy. So before going to that, we will recall the formula of a potential. In the potential formula we have read V is equal to W by Q. That is work done by charge. Now we can write from this formula W is equal to VQ. Is it clear? Work done is equal to V, that means potential difference or potential into charge. So what work is done, or when the work is done, or how much work is done, or where the work is done? The work is done to transport electrons in the electric circuit. Clear? So when electrons are transported or electrons flow from one negative terminal to the positive terminal of the battery in an external circuit, at that time some work is done. That work is done by electric energy. So here we can write, or we can write E is equal to VQ, where this E is electric energy. So E is electric energy, E is equal to VQ. So this is the first equation, equation number 1, first formula, E is equal to VQ. Now we have read Ohm's law. In Ohm's law we have, in Ohm's law V is equal to IR, and in current concept, electric current concept, also we have Q is equal to IT. Now put here. So we can write E is equal to IR into IT is equal to, I can write I square RT. This is number 2 equation, and the formula E is equal to electric energy is equal to I square RT. Clear? So first formula is E is equal to VQ. Second formula is E is equal to I square RT. Now next, as we have read E is equal to VQ, we have read E is equal to VQ and put here Q is equal to IT. This is the number 1 equation. Putting Q is equal to IT, we can write E is equal to VIT. This is number 2 equation. Here Q is equal to IT, and put the E is equal to IR into IT is equal to I square RT. This is the number 3 equation. V is equal to IR. Clear? This is the three formulas. Next, we have I is equal to V, we know V is equal to IR, or I is equal to V by R here. Put here. So we can write here E is equal to, in place of I, V by R into R square, V by R square into R into T. So it will be V square by R into T. This is the number 4 equation. Here I is equal to V by R. So these four formulas are different formulas for electric energy. Clear? E is equal to VQ, E is equal to VIT, E is equal to I square RT, E is equal to V square by R into T. These four formulas are different formulas for electric energy. Now, what is the unit of electric energy? The SI unit of electric energy is kilowatt hour. Kilowatt hour we can write kWh, and CGS unit we can write or we can write only unit. Unit we can write, one unit is kilowatt hour and another unit is watt hour, WH. So there are two units of electric energy, one is kilowatt hour and another is watt hour. Now, what is 1 kilowatt hour? So we can write, when an appliance of a power 1 kilowatt works for 1 hour, then electric energy consumed will be 1 kilowatt hour. That means if we will take an electrical appliance whose power is 1 kilowatt and the power appliance will be worked or will work for 1 hour, at that time the energy consumed will be 1 kilowatt hour. And 1 watt hour, just remove kilowatt and put watt. So here 1 watt and this will be 1 watt hour. 1 watt here and 1 watt hour here. That means if the power of the appliance will be 1 watt and it will work for 1 hour, then the electric energy consumed will be 1 watt hour. Clear? Now, this 1 kilowatt hour is called also commercial unit of energy. Commercial unit of energy. Why it is called commercial unit of energy? Because it is used in electricity supply. This unit is used in electricity supply or electricity transmission case. So we can write 1 kilowatt hour is equal to 1 unit. In our house we are using kilowatt hour meter or electric meter. It measures the unit or it measures the electricity or electric energy in kilowatt hour unit, and 1 kilowatt hour will be 1 unit. We just see how many units are there or what is the reading of the electric meter, how many units are consumed in 1 month. Suppose our meter is consuming 40 units or 50 units or 100 units a month. It means we are using, or we have used 100 kilowatt hour energy. We have consumed 100 kilowatt hour energy in that particular month. Clear? Okay. Now, we have read before that the unit of energy is Joule. Electricity is also a form of energy. Why this unit of energy is not written here, unit of electricity and electric energy is not written here Joule, or what is the relationship between kilowatt hour and Joule? So we will just write relationship between kilowatt hour and Joule. We can write 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt is 1000 watt. Kilo means 1000. 1000 watt into 3600 seconds. So it will be 10 to the power 3 watt into 3.6 into 10 to the power 3 second. I have told you in the video that every physical quantity is expressed in the form of their order of magnitude with 1 digit left to the decimal point. Here you see we have not written 3600 second, we have written just 3.6 into 10 to the power 3 second. So we can write 10 to the power 3 plus 3 is 6. Watt into second is Joule. So it will be 10 to the power 6 Joule. So 1 kilowatt hour will be equal to, it will be 3.6 is equal to 3.6 into 10 to the power 6 Joule. So 1 kilowatt hour will be equal to 3.6 into 10 to the power 6 Joule. Now we will read about electric power. Symbol is P, capital P. In work and energy chapter we have read power is the rate of change of work or rate of doing work. So here electric power, we can write it is the rate of consumption of electric energy. The rate of consumption of electric energy, or we can write power, electric power is equal to electric energy by time, because rate means divided by time. So electric energy by time will be equal to electric power. So we can write here P is equal to E by T. P is equal to E by T. So first formula we have read. E first formula is VQ. So we can write equal to VQ by T. Because electric energy first formula will be VQ, so we can write VQ by T is equal to, I can write VIT by T is equal to, I can write VI. P is equal to VI. Clear? So also we can write, imply that P is equal to I square RT by T, or I can write I square R. Also I can write P is equal to V square by R into T by T. I can write V square by R. So this is 1 or this is 5, 6, 7, 8. These 4 equations are the formulas for electric power. Now, just look at the formula 3, formula number 6. Power is equal to VI. We have power is equal to VI, or I can write I is equal to P by V. Yes, I is electric current. So here what is I? So here I is called safe current. Now what is safe current? The safe current is the maximum amount of current it is the maximum amount of current that can flow in a circuit without damaging it. That means the maximum current which can flow in the electric circuit without damaging the electric circuit. Suppose the electric circuit is designed to allow 10 ampere of current to flow. So the 10 ampere of current is the maximum current which can flow without damaging the circuit, or we can say that is the safe current. So today we will read up to this. In next class we will go to next part of this chapter. You will read the chapter or the content whatever taught from your book, use any reference book, solve the numerical problems. Anything doubt you just message in the comment box or message in my WhatsApp number. I will try to solve all your doubts. So read carefully, sincerely, try to understand everything, and whatever the doubts will be cleared in the next video. Thank you everybody.